Okay, so this problem is on page 351, and it's a continuous random variable, meaning that it doesn't have to take an integer value. It could be anything. So for instance, we're talking about women's heights, and a woman could be 63.29 inches, or anything in between. It doesn't have to be an actual integer value like 64 exactly or 65 exactly. Okay, so let's take a look at what this looks like. This is a lot like chapter 2. Remember that normal density curve? Let me draw that. So it looks like this, right? Something like this. And right in the middle is 64. So we're saying that basically a fair amount of people are average in this area, plus or minus a few inches, right? There's not a lot of, there's not that much area under the curve up here, because these are really tall women and these are really short women. So everybody's kind of in this area. Okay, so here we go. We've got the average is 64, so for our population, mu, and a standard deviation of 2.7. So what does that kind of tell us, just as a review? So if we go 2.7 inches on either side of this, what does that look like? So what that tells us is, let's see, well, do you remember what's in between one standard deviation on either side of the average or the mean? Well, there's 68%. Approximately 68% of our data is between those two numbers. So we really just do it just like we did in chapter 2, except we change the wording to be, it's about the probability. We have a 68% chance that if we pick a random woman from this population, she would be between 61.3 inches tall and 66.7 inches tall. Okay? So that gets us started. Now, but in the problem, they want us to say what? What is the probability that we pick a woman at random and she's between 68 and 70 inches tall? So I'm going to go to the next slide and see what that looks like. Okay, so here we go. Let's see, I want to find out the area between 68 and 70, right there. Now, I kind of have to know how many standard deviations I am above the mean. So how many of these 2.7s, is it 1, is it 2, is it less, is it 1.5? How many of these standard deviations am I above 64 to get to 68? How do we do that? Z-score. Okay, let's do that. So the z-score for this situation would be, we go with 68 inches, right, minus your mean divided by the standard deviation, 2.7. And we'd also do the same thing for 70 inches. So 70 minus 64 divided by 2.7. So we're going to basically translate these heights into how many standard deviations am I above the mean. Okay, it's kind of like normalizing the curve, I guess they would say. Okay, so what do we get for that? So there are our two z-scores, 1.48 and 2.22. So what I'm going to do is I'm going to use normal CDF in the calculator. The way we get there is second vars. And first I'm going to say, well, what's the area all the way from 2.22 all the way down, all of this graph, the entire thing? So I put in negative 1,000 to 2.22 and see what that gives me. So it's quite a bit of the graph. 98% of the graph is 2.2 standard deviations above the mean and below. And then I would say, well, why don't I figure out 1.48 and figure out that area right there, and then I would subtract those two to figure out what I have left. which is what I'm interested in right there. So if I do the 1.48, so when I subtract those two right there, like this, I'm going to subtract them, I end up with, it is 0.0562, 0.0562. What does that number tell us? Well, if we translate it into a percent, it would say that we have approximately a 5.6% chance of, if we pick a woman at random from this population, we have a 5.6% chance that they would be between 68 and 70 inches tall. So there's that. Now, here's the deal. My goal is for us to start doing problems on Monday. So less of me lecturing and talking and more of you doing the math. Okay, anyway, I'm going to go and I'll see you on Monday. Bye.